Hello everyone, this is Maharashtra State Textbook, chapter number 2, Quadratic Equation. So we're going to start this chapter, which is second chapter of your textbook, Quadratic Equation. We will begin with basic information about quadratic equation. What is quadratic equation? What is general form of quadratic equation? So basically, here ax square plus bx plus c equals to 0. This is standard and general form of quadratic equation where a, b, c are real numbers and x is variable. So any equation which is in this form can be considered as quadratic equation. But here we have some condition like a should not be equals to 0, because for being quadratic equation it is important that the highest degree of the equation should be 2. If your a is 0, this equation will not remain as quadratic equation. For example, if I'll substitute 0 on the place of a, so this equation will look like this: ax square plus bx plus c equals to 0. So which can be written as bx plus c is 0. As you can see here, the highest degree of power of this equation is 1. So this equation cannot be considered as quadratic equation. That is the reason a should not be equals to 0. What if b or c is 0? So suppose if b is 0, then this equation will become ax square plus c equals to 0. This can be considered as quadratic equation because highest degree is 2. Now further, if c is 0, then this equation will become ax square plus bx equals to 0, and even this equation will remain as quadratic equation. So that is the reason a should not be equals to 0. So hope it is clear that what is required for being a quadratic equation, the highest degree of the equation should be 2. A quadratic equation must have two sides, left hand side and right hand side. On left hand side you will get three terms: ax square plus bx plus c, where a, b, c are any real number and x is a variable. Okay, this is practice set number 2.1 of our Maharashtra State textbook, where the first question is write any two quadratic equations. So as we discuss what is the quadratic equation and what are the general form of quadratic equation, this is actually open-ended question. Everybody can write any two quadratic equation as per their choices. There is no condition. I'll give you some example, like you can say uh, 2x square minus 5x plus 6 equals to 0. This can be considered as quadratic equation because the highest degree of the equation is this equation is 2, where the 2 minus 5 and 6 are a, b, c, which are real numbers, and it has only one variable, that is x. Another example which we can take, like m square plus 3m minus 5 by 2. Now this is again a quadratic equation where m is a single variable. This m square has no coefficient, so we can consider 1 as a. This plus 3 is b, and minus 5 by 2 is c. So in same way, in same manner, you can make infinite number of quadratic equation which must satisfy the basic criteria for being a quadratic equation, which we have already discussed, that they should be in the given form like ax square plus bx plus c equals to 0. So any equation which is in this form can be considered as quadratic equation. Now let's move on next question. We have another question. Decide which of the following are quadratic equation. So this is another question. So as you can see, your first equation, this one, x square plus 5x minus 2. So here it is clearly uh, observe that this equation is in proper standard form, so we can consider this equation as quadratic equation. So this is your question number 2. Decide which of the following are quadratic equation. Here we have 6 questions. I already taken all 6 questions on my sheet. We will discuss one by one which of them are quadratic and which of them are not non-quadratic. So this is your question number 1. This is question number 1. X square plus 5x minus 2 is 0. So it's look like ax square plus bx plus c equals to 0. So this is quadratic. So it is quadratic equation, right? Y square equals to 5y minus 10. So first you need to write this equation in proper standard form, keeping y square on its place. This is positive y, so I can bring it to the left hand side. It will become minus 5y, and this is negative 10. When I'll bring it to the right hand side, it will become positive 10. It's 0. Now even this equation is in proper standard form of quadratic equation where the highest degree is 2. Only one variable we have, and a, b, c are real numbers. So even this equation number 2 is a quadratic equation. Now let's move on this question number 3. So even it is same as question number 2. Here we have y square plus 14 1y is 2. So you can bring this 2 to this side, it will become minus 2 equals to 0. So this is also a quadratic equation. Yes. Then we have this equation, even it is same as previous two, question number 2 and 3. Now move on question number 5. This question number 5 is m plus 2 m minus 1 m minus 5 is 0. This is question number 5. We can simplify this equation to verify whether it is the quadratic equation or not. So I can multiply this bracket with this m. So this m will give me m square. Then for plus m minus 5 will become minus 5m, 2 into m, that is plus 2m, and this plus and minus will become minus, and 2 5s are 10 equals to 0. So therefore m square, this is negative 5m and positive 2m. So minus plus minus, but we will take sign of greater number, and I think 5m is greater, so here I'll take minus. 5 minus 2, that is 3m minus 10. So when you simplify this equation number 5, it will look like this. And this can be considered as ax square, where a is 1. This is bx plus c equals to 0. So even this equation number 5 is in proper standard form, where the highest degree is 2 and equation has only one variable, that is m, and value of a, b, c are 1, -3 and -10 respectively. So the same way we can solve this equation. Look at this. This is m cube. This equation is something like this. So this question number 6. Actually, I copied these questions from PDF, so the orientation of question is not so proper. So this equation can be written as m cube plus 3m square minus 2 is equals to 3m cube. Now we need to identify whether it is quadratic or not. So I can bring all these numbers to the left hand side or right hand side. So this will look like 3m cube. This is positive 3m cube. So we can take negative 3m cube minus 3m square plus 2 is 0. Now this is 3m cube and this is minus 1m cube, will give you 2m cube minus 3m square plus 2 is equals to 0. Now this is a more simplified form of this given equation number 6. As you can observe, in this equation the highest degree is 3, but for being quadratic equation, highest degree should be square. So you can say this is not a quadratic equation because highest degree is more than 2 or greater than 2. So we done with this question number 2. Now let's move on question number 3. This is our question number 3. Right, this question number 3 is about write the following question in the form of ax square plus bx plus c equals to 0. Then write the value of a, b, c for each question. It is same as question number 2. In question number 2, we decided whether the given equations are quadratic or not. But for this question, you need to arrange the given equation in this standard form and then find the value of a, b, c. We will take some question from this, for example, this question number 1. 2y, this is minus y square. So here I can say, I can bring this minus y square to the left hand side. It will become plus y square. This side we have plus 2y equals to, on the right hand side we have 10 more. So I can bring it to the left hand side, will become minus 10 is equals to 0. Now this equation number 1 is in proper standard form, that is ax square plus bx plus c equals to 0. Now we will compare this equation with this standard form to get the value of a, b and c. So here you can say, actually a is coefficient of first term, b is coefficient of second term, c is coefficient of third term. So our first term is y square, so there is no number, so I can consider 1. So a is 1, same way b is 2, b is 2, c is minus 10, c is minus 10. So this is the way you can find out uh, value of a, b, c. Now we will not spend more time on this. Let's move on next question. Question number 4. Determine whether the values given against